All right, friends and neighbors, welcome back. We are doing Chapter 17 of Volume 2, Cisco CCNA, Software Defined Access. Now, if you're a little confused on all of this software-defined stuff and all of that, we're going to talk through some of the basic architecture here, and we're also going to cover the Cisco version of that. So as we hopefully get through all these terms and everything and do some examples, then it'll start to coalesce for you. So as always, we'll do the key topics. Our exam section this time is network fundamentals, but the role and function of controllers, and in this case, the DNA controller. And of course, all of this stuff, the software-defined network, is all about automation and programmability, centralizing network management and control in a controller so that we can touch the control plane via the southbound interface and maybe add some programmability via the northbound interface. And of course, along the way, we're comparing traditional and controller-based architecture. We'll touch on that. But this time, we're really going to spend time on the overlay, the underlay, the fabric. And we'll remind ourselves what the NBIs and SBIs are. And we'll polish off with the do I know this already questions. So our key topics, as I mentioned, we're going to do the overlay and the underlay. And we're going to add to our discussion VXLAN, which is our tunneling protocol. And so the overlay and underlay that we're going to talk about here are specific to SDA, which is the software defined access for Cisco. And then we've got a couple of nodes here in what we're going to call sort of our SBA cloud. And we'll go over the attributes of all of these components and what appears at various layers. And then we'll do an example of the VXLAN encapsulation with the software-defined architecture. It's not unlike our 802.1q tunneling that we've done or the trunking that we've done or MPLX. And then the featured feature, I suppose, is a security implementation that we'll see with the controller and the SBA architecture. Okay, so overlay and underlay. So if you think about this for a sec, right? If we think about traditional networks, and that's part of what our exam topic is going to be, comparing traditional and the controller-based architecture. We have our network layer 2 connectivity, right? Everybody in your network, everybody in your layer 2 connection, everybody in your VLAN. And then you've got the routing in between VLANs. You got the routing in between networks, whichever way you want to think about it, or what jumps to mind when you think about routing. And then the routing protocols. That's a very traditional approach to this. But the controller-based architecture, as we know, is sort of a new way to look at network management and control by separating out all of those data planes, right? The data plane, just packets flowing, the control of how they flow, where the endpoints are, and then the management, how we're going to touch all of that stuff. Now, the SDA, the software defined access, is a completely new way from Cisco to build the campus LANs, but it's based on, right, the SDN or controller model that we have. At the center is the controller, or in this case for Cisco, the DNA, the Digital Network Architecture Center Controller. So the idea is the same, right? The controller is going to reach down via the southbound interfaces and touch all of the network devices with a twist. That twist is VXLAN. And you're going to manage this via a GUI, a single pane of glass, right? You get to touch everything from one place. That's one of the benefits of the SDA architecture. And via the northbound interface. And so here's our definitions, right? The overlay is the mechanisms to create VXLAN tunnels. Now, I'll get to VXLAN here in a second. But the VXLAN tunnels, so I've got an endpoint over here and I've got an endpoint over here, and the way that they're going to communicate with each other is via an SDN-based VXLAN tunnel if the controller says that it's okay. Now, the underlay is exactly what you might think of. It is the collection of network devices and cabling and everything else that we use to forward that traffic. And the fabric is just the collection of all of those thingies. So if you look above me here, we can see that we've got this sort of cloud here. So all of the connections are going to be in this VXLAN cloud. All the endpoints are going to be connected via VXLAN tunnels. And what allows or facilitates the configuration of the VXLAN tunnels? The overlay, or in this case, the controller. And we're going to use all of the network devices and connectivity as our underlay. So that's how we sort of put this whole thing together. So let's talk a little bit more about the underlay. It's pretty straightforward when you think about devices, right? We've got our switches, we've got our routers, we've got our endpoints, we've got our cabling, all that stuff that we're going to use to send traffic along our pathways. And it doesn't matter if you have a 2-layer design or 3-layer design. Remember, we're not talking SOHO networks, we're talking campus. So we're going to think about the 2 or 3-layer designs. And then the goal here is to not disrupt endpoint connectivity. So it doesn't matter if we're talking about a traditional viewpoint or if we're migrating to SDA or if we're going to do brand new SDA implementation. We don't want to disrupt endpoint connectivity. Okay, so let's say that you're in a traditional network architecture, right? You're not doing software defined, you're not doing controller based at all. You're doing a very traditional approach to your data and control planes. And then you say, all right, we're going to switch over to SDA, software defined architecture or software defined access. How do we do that? Well, one way, we'll take the greenfield approach first. So let's say that you decide, oh, we're going to go whole hog on this. We are going to buy a whole bunch of SDA gear. Well, so you do that. You buy a whole bunch of equipment that's capable of understanding the directives from the controller, capable of understanding the software-defined access architecture, and capable of communicating with a controller, and capable of VXLAN. And then one by one, you migrate your endpoints over to that architecture or your data flows. Now, another way to go is that if you have your gear and you don't want to buy brand new stuff, you can take a look to see if your equipment supports the SDA architecture, the software-defined access architecture. I'll say it that way. If it does support the architecture, then you might be golden, and now you're going to just slowly configure your gear and move some stuff to a new configuration to communicate with a controller and to move your endpoints that are connected to those devices into the SDA architecture. So that's sort of our two approaches here. But in either case, right, you have to build the configurations, you have to decide roles for the nodes, and we've got that cloud, right, that VXLAN cloud. And so we've got edge and border and control nodes in our fabric that are going to decide how we're going to forward things. So everything that lives inside the software-defined access architecture that might be talking with the DNA controller is going to be part of the fabric, and therefore may have a role in the fabric. So now this all sounds pretty doggone confusing if you're just getting used to the terminology. But if you're familiar with wireless gear, we've done this model already, right? If you're a campus or you're an enterprise and you say, well, we're going to do wireless, and we've got 100, 200, 1,000 access points. Well, how do you manage all of that? Well, today, when we have a lot of access points, we do a controller. So the controller reaches out and touches all of the access points to push configurations, to do security, to centralize AAA operations, and there's a tunnel that is set up between the controller and the access points. So they already have this architecture in a centralized model. So this is not something that's brand new, never been seen before, but it is a way to wrap your arms around your entire architecture. So some major differences between the traditional underlay and the SDA overlay. Consider how we do things in a traditional model. Now, if you're uber traditional, then you have layer 2 and layer 3 devices. So you have switches, and that's what they do, layer 2 switches. They understand MAC addresses and VLANs and things like that. And then you've got routers. Smaller number of ports, they route, they handle ACLs, they do network address translation, and that's it. If you're a little more, toward this decade, then you have layer 3 switches that can do routing, that can understand a little bit more about the topology, so on. Okay, so in that model, the layer 3 switches might be the default gateways for hosts, right? Because you can give the VLANs their IP addresses, and then you can route between the VLANs. Okay. We might add things like hot standby routing protocol to add availability, right, to increase our availability. And then wherever we've got layer 2 loops and things like that, we'll handle that with rapid spanning tree. Okay, so that's the very traditional sort of viewpoint. In a greenfield SDA build, the fabric uses a routed access layer design. Okay, so first of all, I don't want to blow right by the greenfield term. If you've never heard that before, there's two ways to look at network design when we're doing either an upgrade or we're doing a brand new network design. If you're going to modify an existing design or upgrade a network, we sometimes call that brownfield, in the sense that you're not walking into a pristine pasture and you can do anything you want, right? So that's brownfield. Greenfield is where we say, all right, look, we're going to start from scratch. We're going to design this from the ground up, and we're not going to worry about legacy equipment or anything like that. So in a greenfield SDA, meaning that that's what you're doing, right? You have the controller, you're doing SDA everywhere, all the switches understand SDA, they're all doing layer 3 stuff, and you're going to do VXLAN. Everything is routed everywhere. So the VXLAN tunnels for everybody are going to provide the endpoint connectivity. And all switches are layer 3 switches because the endpoints are going to have their IP address, the endpoints of the VXLAN tunnels are going to have IP addresses, and then you might have a substrate on top of that. In addition, the switches are routing between each other using ISIS, and so we don't need hot standby routing or a rapid spanning tree in that case. Rapid spanning tree should make sense because we're not doing layer 2 stuff anymore. And the DNA controller is reaching out and touching everything. So the controller configures all of the device underlay connections. So now two endpoints want to communicate. They talk to the controller, and the controller says, all right, my policy says you're okay. Let's set up a VXLAN tunnel to enable you to communicate. And in this case, we're not worried about disruption to our endpoint connectivity because the controller knows all, sees all. So that's sort of our differences between the underlay. There's a lot of separation between device responsibility and the ability to break things in the traditional model that don't exist in the controller base because the controller can see everything. All right, so the SDN overlay. Now let's remind ourselves about how 802.1q trunking works, right? If I have two switches that are talking to each other, and you can go back and look at your VLANs and trunks videos, but if I have two switches that are talking to each other, and I've got traffic going between them, and there's a trunk line in between, then the switch that sends the traffic does an internal tagging, sticks a tag inside the Ethernet frame, the 802.1q header, or in Cisco speak, the .1q. So the Ethernet frame is actually changed. You even have to recalculate the CRC, and the 802.1q header has a new ether type, 8100. The receiving switch removes all of that, so does all the work all over again, removes the tag, recalculates the CRC, and then finally forwards it on to the proper destination. When we talked about MPLS, we had an MPLS cloud, and the MPLS switches on the edges of the cloud would modify the header to include the MPLS header, and then the forwarding through the cloud would be based on the MPLS tag. And then at the egress of the cloud, the tag would be removed. Very similar idea here. In the SDN overlay, what we're going to do is we're going to create these VXLAN tunnels that are above me here, right? So I've got endpoints, And so these two endpoints are communicating via a VXLAN tunnel, and these two nodes are also communicating over a different VXLAN tunnel. Well, what set up the VXLAN tunnel? The controller. So the node said, hey, we'd like to talk to each other. We'd like a VXLAN tunnel set up. And again, if the controller says that it's okay and the nodes are reachable, we'll set up a tunnel. You can also see some of the addressing in this example. We've got the 192.168 network, and then the tunnels themselves are on potentially a different network with our layer 3 connectivity on yet another network. And this, of course, reminds us that you can have a production network and then you can have your management networks on top of that. So when this traffic leaves, the VXLAN tags or header is included and then it's sent to the destination, and the receiving switch removes all that stuff. So it's very, very similar. The difference here is that there's a controller in the middle that's deciding how this is going to work. Now, one thing that the chapter talks about is the performance hit. Well, that sounds like a lot of work. In fact, .1Q tags, MPLS tags, and VXLAN tags, they add more work. But remember, in the last video, we talked about the application-specific integrated circuits, whose job it is to handle this kind of stuff specifically. And so that work is now done by the ASICs, and so it's little or no performance hit. Now, VXLAN is actually short for Virtual Extensible LAN headers, and so we're actually going to stick something in the frame that has additional information. We're actually going to wrap the whole frame in this header and add another one. And the nice thing about VXLAN is it also adds additional capabilities that allow us to extend what the controller can do, not just see into the network. So again, reminding ourselves how a traditional network operates. The switches will learn the MAC addresses the minute you generate traffic, and they put you in the source address table or the MAC address table, and they tie your MAC address to a port. And then the routers either are statically configured or they're doing dynamic routing or routing protocol or something like that, and they store all of that information in a routing table, which is a mapping between the network destinations and an interface that we're going to use to get to that destination. So that's very traditional. In the controller-based model, we're going to do things maybe a little bit different. So we can dismiss a lot of these discovery mechanisms that we have, and instead, the endpoints are going to register their locations with the edge devices, maybe the fabric edge devices. And then we're going to register those locations and another detail called the routing location with a server that's out there. Now, in this case, the server is going to be a Lisp server, Location ID Separation Protocol server, and store this information for later when we might need it. So some node wants to communicate with this node. Can we identify that the node is around and figure out where it is? Now, Lisp is actually an RFC, so it seems like it's a Cisco-specific thing, but it's not. There's an RFC out there, 6830, so you can take a peek there. I don't want to spend a lot of time on Lisp routing right now, but this protocol exists as an internet standard. So what we might do in an SDA architecture is two nodes want to communicate. They would go out and make a query to the Lisp server and see if that node is there. Has it registered? Do we know where it is? And then we might be able to build a VXLAN tunnel to its destination. Now above me here you can see that there's this VXLAN header. So here's the original frame that we might have sent, and then there's this VXLAN header, and all of the stuff that's specific to VXLAN or getting this tunnel between the tunnel endpoint on one end and the tunnel endpoint on the other one. And then we've got what we might do with features or with the tags in VXLAN itself. So we can see there's definitely an encapsulation here. And in fact, if you look at the capture, you'll have what appears to be a couple of repeated headers here, but one is specific to the tunnel and one is specific to the original data. Now, this is not unusual either. If you do GRE tunnels, you'll see that there's actually 2 IP headers in a GRE tunnel. So the DNA center controller can manage either traditional or SDA topologies. And as we know, when we talk about migration, if you have gear that's on the compatibility list, your equipment might be able to talk to a controller or be active in an SDA topology without buying new gear. Or, of course, you could get the new gear that's designed to work with all this stuff and replace your equipment. So the DNA center controller can manage either one. And of course, when we were talking about the controller-based model, when we were talking about SDN, the DNA center controller does all of that, right? So it has the northbound interface and the REST API. It has the GUI for users. It does the communication via JSON and HTTP. And then on the southbound side, right, it controls devices. But it also has the ability to communicate with traditional devices via SNMP or SSH or something like that. And then there are some other architectures out there, netconfig and restconfig, that it's also able to do. Now, the feature that the chapter focuses on is something called scalable groups. And the problem is that's sort of outlined as ACLs, access control lists, right? So if you remember when we were doing access control lists, you create your filter rules, right? Your access control list entries, and they don't actually do anything until you apply them to an interface and direction. Now, over time, what might happen is that you update your ACLs. So you've got a couple of rules in there, and then you add some more entries. And then later on, somebody else adds some more entries. And after a while, you wind up with a whole bunch of entries in this access control list. And it becomes harder and harder to figure out what the impact of one of your changes might be. So you say, all right, I'm going to do a tweak to this. I've been asked by my boss to update our security policy or to clean up the ACLs, whatever it is. And you say, okay, I'm going to make this change. If I make this change in this access control list series of statements, what's going to happen? Not always easy to tell. In addition, some of the lines might be overlapping, right? You might have, well, this group of nodes can do HTTP, but a subset of that nodes is allowed to do UDP-based operations or TCP-based operations that are similar to, that port number or maybe 8080 or 44, whatever it is. So there's maybe some overlapping. I can tell you from experience that looking at hundreds of ACL lines and trying to understand the impact of a change is time consuming, but also hard to know if you're right. So in the SDA model, you don't set up access control lists anymore. What you do instead is that you tell the controller what your security policies are. This node, this individual, this department, this collection of nodes are allowed to do the following things, and they're not allowed to do the following things. And they're all sort of separate ideas. So now, when nodes want to communicate, what the controller does is says, are you allowed to do that? The policies then are adhered to without trying to determine whether or not one steps on the other. And you can remove a policy without affecting the other ones because they live independently of each other. So the important idea there is that when two nodes want to establish the connection, the controller is contacted, and maybe the list server is contacted to see A, if the node is available, if we know where it is, but also if what you're trying to do is even allowed. Then and only then might we build a VXLAN tunnel. All right, so hopefully at this point you've got an idea of how the DNA center controller and the software-defined access sort of operates. The key there is we've got this overlay and underlay, and the mechanism that makes this work is the VXLAN tunnel. But the VXLAN tunnels are only set up when the controller says it's okay. All right, do you know this already? Question number 1. In Cisco Software Defined Access, which term refers to the devices and cabling along with the configuration that allows the network device nodes enough IP connectivity to send IP packets to each other? So that is clearly a description of C, the underlay. Question number 2, in a Cisco Software Defined Access, which term refers to the functions that deliver endpoint packets across the network using tunnels, there you go, keyword and tricky phrase, at the ingress or egress fabric nodes, and this is the overlay, B. Question number 3, in Software Defined Access, which of the answers are part of the overlay data plane, and that would be VXLAN, D. Question number 4, which answers best describe the options of how to implement security with scalable groups, that was the example in the chapter, using DNA Center and STA? Well, that was A and D. A human add a DNA GUI, right? So that would be the single pane of glass, configuring that. So you could configure scalable groups there, or if you had that REST API, right? This is part of the northbound interface, you could do it that way too. So that was D. Question number 5, which of the following protocols or tools could be used as part of the Cisco DNA Center southbound interface? Remember that the DNA Center supports a variety of topologies, SDA and traditional, so SSH, NetConf, and SNMP are all mechanisms that could be used. Question number 6, which of the following are network management features performed by both traditional network management software as well as by the DNA Center? Now, there's a whole bunch of things that the DNA Center does, like that whole path discovery that was an example last video. But in this case, the network discovery, finding the nodes, and device installation, being able to push out configs, are parts that live in both the traditional and the SDA model. The Chapter 18 look ahead, understanding REST and JSON. Remember that when we're dealing with the northbound API, that is going to be a REST API, and so structured in a particular way, right? That HTTP messaging, and the formatting will be JSON based. But related, of course, is the HTTP protocol itself, XML, YAML. These are all other ways to organize your model language and the descriptions and everything else. So these are all related. And then REST and XML and YAML are all referring to how we build a data model and how we interact with that data model itself. So we've got to have some way to organize the queries and the structure, and so these are all related to data models and data serialization. But we'll talk more about that next time. So this has been software defined access. Remember, we did that whole controller-based security example. And the section on the exam that we're really after in this particular chapter was 6.4, compare traditional campus device management with the Cisco DNA Center enabled device management. And there's a whole bunch of things there, right? The minute we're centralized, we can reach out and configure everything, manage everything via the southbound interface, but we get to do that sort of set of policies that control not only user access, but how devices set up those VXLAN tunnels. So there's a whole bunch of things that we gain by having a controller-based model and centralized management. So that was the whole topic of this particular chapter. All right, well, we know the look ahead now, so like and subscribe for a little rest. And whether you're still doing traditional and maybe way traditional, right? Routers and switches that live only at layers 3 and 2, or you're doing layer 3 switches, or you're doing the software defined access with a controller. May those packets always reach their destinations. And hey, we're CCNAing. We're almost there. You can do this.